the solutions to all of those problems or samples or whichever worksheets that we have by now is being posted, right? So, you can find them over the assignments. If you have like worksheets, after the worksheet number 5, right? So relations, counting, binomials, and graph, pigeonhole. So these are included in this one. I like really counting worksheets because it's really good combinations of whichever you needed right now for probability again. But again, if you click it on those, so you have had the worksheets before, now you have the solutions to that. So you can check the solutions to your worksheets on that place. The same place that you saw your worksheet. Pigeonhole actually was with the solution, but still I post the rest of the problems solutions, the rest of the problem solutions. You can just check it over here. Okay, I added the handwriting and then I ask Hamid to make it all typed. This one, where is it? I think I made one mistake for yours. And then that's a binomial. I have to update your worksheet solution for this one. You don't have this one, but the rest is there. Anything else you guys needed? Anything else? Any other files? So again, if you want to get ready for the test, you really need to try the problems that we did enough examples during class times, right? So you need to really practice all of the problems that we did during the class time. If you feel you can finish it in one night, that's impossible, right? So it's many, I will say, sections and chapters that in this time. So it's just 5 of them, right? So you have, what was the list of them? You have counting probability, which was connected. So if you know the counting probability, it's very similar problems, except the conditional probability, which is a good one with that trees. Then your sequences, that's another chapter. And then you have your graph theory and relations, right?
Is graph theory going to be on the picture?
Yeah.
Yeah.
Why you say?
Because we didn't have a quiz for it. That's why I asked.
Because it was just really easy. Huh?
Okay. That makes sense.
Yeah, all of the sections are, right? So, I mean, for you guys, because of your major, I think you have many ideas about the graph theory. The thing that we are covering here is really basic. You know much more than that in your other courses. So just the only thing is the minimum spanning tree is the most important part that you need to know. And then how you just check whether it has Euler tool or not, right? So Hamiltonian cycle, check for the Euler tool and check for the minimum spanning tree. So that's just the only 3 top possible questions we can have from the graph theory. But it's included in this test. And then what we have, sequences. Then
That one was a little bit tricky.
Counting and probability, relations, and then just equivalence relation or partial order relations, and then the graph theory. So it's a five chapters. If you guys leave it for a very last night, which is tomorrow night, it's impossible to finish it, okay? I'm hoping you guys have started by now. For the review session, I just had the conversation for the other class that will be tomorrow night. So I will say 8, something like 8:10, maybe 8:15, because I have to pick up my son from the classes. So I think 8, it should be fine, but I will say 8:10 to make sure. So I am available right time. You don't have to wait for me. You have the Zoom meeting ID, right? The one that we use for office hours. So it's the same thing. You had something to ask? I think wrongly you made a wrong date for that place. So you have to fix it. Okay. Because it says tonight. I mean, it says Monday, but it's not Monday. So you have to make it Wednesday. That's what it says on my email. So you have to fix that. What else? So again, today I'm just practicing more problems of this, what was it? lecture note that I have had before. And that is a good practice for probability, again, the simple probability and conditional probability. And then we can just move on to what we have on sample test, okay? So if we couldn't finish on sample test, we can post the solutions. You can just join to the meeting. I'll for sure record that meeting that is on Tuesday night, but tomorrow night. Yeah, tomorrow night. And then we'll try to make it available soon, okay? Anyone has anything to add, any comment, any question? Everything is clear? Okay. So that is one example. If you guys have the lecture note, this is what I want to start with. So the top doesn't have that much examples, or it's just really one thing that we practiced before. This one, we did it before, exactly same numbers, same thing, false negative and then false positive. So this is, I think I have 3 nice examples here. The 5th one is what we tried before, okay? So let's start from this one. First of all, for the relation that's on the top, it's just real probability of E given F plus probability of not E given F is going to be 1. So addition of these 2 probability are complementary and it's going to be 1. Okay, so I don't know, you guys writing the problem or not? So this is what it is. It says the following questions is about the experiment that you have a blue and red dice. Express the probability and simplify the fraction, which we don't know. We don't want it. Actually, in a test, I don't like to simplify. I like the answer to be in the way that I write on the board. Okay, so you don't want to just simplify or put it what's the factorial number for that. It takes time. It wastes your time. Okay, so forget about that. What is the probability of the sum is at least 10 given 2 die have the same number. So first of all, what is the probability of, let's say, what's the event F? So I defined my event F to be the one that you have the same die, the same number, sorry. What's the chance? There are 2. And then you want to have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. How many chances? What is it? How many chances to have the same number on both die? 6 out of 36. So the E, what's the probability of sum of at least 10?
Will just be one of them?
No, I think it's more. That's why I'm making the table. I think that helps you, because if you have such this problem, you know, it's 36 possible cases. So you can just make this one. I will write 1, 2, 3, 4, 5, and then I need one more. And that is seeing really in one glance all of those possible cases. So that's 1, 2, 3, 4, 5, and then 6. So you see this 6 and 6 is one case, it gives you more than 10. The 5 and 6 gives you 6 and 5 gives you more than 10. 5 and 5 gives you more than 10. And then equality is there, right? So then you have 6 and 4, and then you have also 4 and 6, right? So 1, 2, 3, 4, 5, 6 cases. Does it make sense? Do you agree? So if you want to write the probability of conditional, so what is it? Probability of the sum is at least 10. The sum is at least 10, so which is E. given the two die have the same number, so given F. So it's going to be probability of E given, intersection of the, sorry, why I wrote like that? Probability of E intersection F divided by probability of, what's the denominator, F, okay? So that's the formula. So let's see out of these cases that I have here, what's the probability of intersection? So that's because the denominator or sample space is the same. It's going to be really the size of what's the intersection of these two divided by the size of the F. So you had the F was 6 cases. So the F was six cases. What's the probability of the sum to be 10 and they both to be the same number? How many?
Be the same number one.
So to be the same number and bigger than equals 10, right? Intersection. Two, right? So it's two of them. It's this one and this one, right? So it's two of them. Yeah, that's just wanted. The answer is wanted. Agree? Any question for this one? Any question for this one? What is the probability of the sum is less than 10, given that the two die have the same number? So these two are complementary, right? So they are complement of each other. So if you have at least 10, the complement is less than 10, not equals, less than 10, okay? According to the rule that's on top, so if you already know what's the probability of E given F, and you're looking for E bar given F, so you have to say 1 minus probability of E bar. I'm sorry, I don't know why I have extra bar. E given F, okay? So your previous part, for previous part is complement of this part 2. So it's a 2/3. I'm going to write over here. I should write first. At least, sorry. Some less than 10. Some less than 10, okay? Make sense? I give it this one. Move on. The third one, what's the probability of that the sum is at least 10 given the blue die comes 2? At least 10 was part E, blue die is 2. Blue die is 2. What is it? At least 10. So that means this piece. This is right over here. Does it have any case that the blue die is 2? It's impossible, so it's 0. Okay. So then the fourth, what's the probability of the sum is less than, which is the opposite of that? Sorry, not the opposite, complement of that. So probability of complement blue die to be 2 is 1 minus probability of previous, which actually nothing, right? So it's going to be 100% of the chance, right? So that's complement of the other one. Question.
So for number 4, that would indicate that 100% of the time that would be true.
So probability of the sum is less than 10, given that the blue die is blue.
Oh, got it.
It is going to
That
be,
condition.
yeah, that is 100%. Okay. Question. This is more probably challenging to decide about the probability. So you have the letters A, B, C, D, E, F. You have the letters of A, B, C, D, E, F. And then B falls in the middle. Okay, so B falls in the middle. So then that's a event. This is event A. So then event B is the letter of the C appears to the right of the right side of the B, and then the letters of D, E, F has to be in order is the event C. Okay, first, can we have the probability of each this A and B and C first? What is the chance for probability of A? What do you think? You're having 7 letters. 1, 2, 3, 4, 5, 6, 7 letters. And then it says for probability of A, it says B has to be in the middle. What would be the other permutations if the B is in the middle? Six only? Go ahead. And 1 out of 7. It is 1 out of 7, and it's coming actually with the, you're having 1, 2, 3, 4, 5, 6 place, which takes 6 factorial for this, any permutation between them, right? So you will have 6 factorial for any permutation between them, because in the first place, you have 6 letters available. In second, you have 5 letters available. For the next one, you have 4 letters available. And the next one, you have 3, and then 2 and 1. So that's the total case of 6 factorials that your B is reading in the middle, because B is fixed. There is 6 factorials available. And then your total sample space has 7 factorial. That's how you get the 1 out of 7. That's true. That's how you get the 1 out of 7, because you have 6 places over here. Okay. Let's get the probability of let's get the probability of the B. Your B says the letter C appears to the right side of the A. Letter C appears to the right side of the B. What do you think? How many cases? 1, 2, 3, 4, 5, 6, 7. Let's say if your B is sitting over here, letter C appears to the right side. Sorry, B can't be here. It says actually one example here, B, D, and then C. So B and then C, like this. Maybe B and then C, like B and then C. Not right after. Okay, so that's the cases we can have. What do you think? No, that's just a problem. It could be really anywhere. No, it could be really anywhere.
So B could technically be in position 1, 0, 6, as long as C is still.
Mm.
This one is also being.
Mm. Any idea? So you want to say because B is sitting here, you have a 6 factorial over here?
Over 6 factorial. The D has to always be to the right of B.
Mm-hmm.
So you have to leave one space over for the 6 factorial as well.
So you mean 6 factorial times 6 factorial?
Yeah, over 6 factorial.
or 6 factor over 6 factorial doesn't make sense because that's just
Yeah, those would be like. all would be like 6 factorial plus 5 factorial, just because like B is moving over each line, so factorial.
yeah, for the other class, they were thinking it the same way. So it was just really 6 factorial and then 5 factorial, and then you have 4 factorial, and then you have, that's the way that I actually kept it, right? So if your B is sitting in the first place, so then you have 6 factorial chance of for the rest of the permutation. If just B is sitting in second place, so then you have all those repeated again. So then what you're saying, I feel, I mean, you can just correct me if I'm right. So I'm wrong. So what you are saying, let's just erase this one. It covers really the cases that I'm writing over here. So you have a 6 factorial here, and then you have another 6 factorial here, and then you have another, 5 factorial here, and then, as you said, it's really reducing the number, right? So just going down at 2 factorial. But how about if your B is sitting over here? Or do I cover really that case? Or you're saying the C?
No, I'm saying if the B moves, that's when the factor decreases. The C only has.
Oh, okay.
It has to be in. Yeah, because every time B moves over one, C is restricted. A little bit more.
So then let's just discuss about, so you're saying if your B is sitting in the first place, if your B is sitting in the first place, you're having exactly 6 factorial cases that the C is sitting on the right side.
When the B is in the first place.
And then if in the second you have 5 factorial, then you second is 4 factorial, 3 factorial, and 2 factorial. And then 1 factorial, right? Do I have 1 factorial left or no? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then here is 1, 2, 3, 4, 5. If I just have 2 factorial, that's it, right? So I don't have the last one. 2 factorial, yeah, I do have the last one, so it's one more. Do you have calculator that count that factorial? Can you add these numbers? Because I have another easier solution for this. What would be 6 factorial, 5 factorial, 4 factorial, 3 factorial, 2 factorial together? So it shouldn't be really a large number. If you guys can just calculate it for me. There is easier way to write that one, but I just want to see, maybe that's the second way. Who has calculator? Just, if you do it faster than me, do it. I don't have factorial here. How come? Oh, no factorial here. Oh, it's here, sorry.
It's 873.
You wrote all of them? 5 factorial. 3 factorial, 2 factorial, and then plus 1. So it's 873. And then what is the 7 factorial half? What is the 7 factorial divided by half? Oh, that's interesting. You know why? Because we are counting the places, 6 factorial is the places that C can be sit, right? We are not counting. So let's say if your B is sitting, that's 7 places. If your B is sitting here, you just say I have 2 factorial chance of the C to be on the right side, okay? But then you're leaving the other permutation that might happen on the left side. So that's why it's not really enough. Not really, what was it? 873 is the answer. You know what? Because the answer is 7 factorial divided by 2. You know why? Because whenever you have a B sitting on the C, there exists another permutation, which is C on the left and then B on the right side, okay? So corresponding by any permutation that B is first, then C, you can switch the place of B and C. There is a corresponding one that you have C the left side and B on the right side. So that means half of the cases of the 7 factorial is the case that C is on the right and B is on the right. Do you agree with this one? Half of the cases of the 7 factorial, if you have a B, then C, then you can switch the C and B, that gives you a new permutation, okay? Half of the cases. That's why it doesn't give you enough, okay? So I can write down what I just explained. That was a good just conversation on the possible cases, but it wasn't enough. It seems we are missing the permutation of the left side. But we can continue because you see the answer is 2,520. That's just really much, much bigger, huh? Chance for permutations. So what I was explained for the B, for every permutation that C is on the right side, on the right side of the B, there exists exactly one other permutation that you switch the place, huh? B is on the right side of the C. Okay, so that's why that sample size is 7 factorial total, but you are half of the cases that your B happens, your event B happens, okay? Question here? Any question? So then I have C. The letter D, F are always in that order and together. So letter C till 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So let's say D, F are all together. What's the possible cases? What is the possible cases? How many permutations do you have? 1, 2, 3, 4 factorial. Okay. The other one is the case that this DEF can be in first place, second place, third place. How many do I have? The permutation of this DEF, no, not the inside now, right? Not the inside. It doesn't have, because DEF is fixed. It's just all, I mean, as it says, it has to be all together. It doesn't have permutation. But the DEF can be here, or can sit here, or can sit here, and it can sit here, or can sit here. So that's the cases. How many cases you have? 1, 2, 3, 4, 5. So you have a 5 displacement for that DEF. So then it's going to be probability of the C, size of the C divided by size of the sample, which is a 4 factorial times 5 divided by 7 factorial. Anyone has extra battery? I don't know what's wrong. This is slow. Hopefully this helps. Okay. Question on this one? Let's try the intersection. Intersections are really interesting problem to discuss. So the B part, which is, sorry, should I give you more time to write down, or you're okay? Right, okay. So what is the probability? No, I did something wrong. Is it this way or this way? No, it was opposite. Sorry. Probability of what? A given C. So it's going to be probability of A intersection C divided by probability of C. Okay. So what is A intersection by C? What is A intersection by C? What is A intersection by C? A says the letter B falls in the middle. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. One extra. 1, 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So what was it? The letter B falls in the middle. That's A. C. The package of D, E, F are together. What's the cases? So let's say D, E, F sits here. How many permutations? How many permutations do you have here? 3 factorial, you mean? Okay. And then there is one more case that DEF could be here. So you have another 3 factorial. Agree with me? Okay. So you have just 2 of those 3 factorial divided by total of C. Where is my C? 4 factorial B. Do you agree when I don't write division or divide by the sample size? You see, because that divide by 7 factorial, that's also divide by 7 factorial. I don't write that one. I just write the size of each one because they cancel out, right? Question here? Any question here? So this time, what's the probability of B given C? So let's decide about intersection of these 2 events. Decide about the intersection. I don't know what's underneath A. Let me just close it and open it again. There is something that it doesn't show the bottom of my page. Sorry. Probably that helps. Okay. Sorry. Here we are, okay. What's the B and C happens at the same time. So the letter C appears on the right side of the B, and then the C, it says D and D, E, F to be together. So if you have 1, 2, 3, 4, 5, 6, and then 7, okay? D, E, F are together. So what would be the cases that, what was it? C appears to the right side of the B. Okay. Half cases, huh? According to the discussion that we have, but it's not 4 factorial. Isn't it 5 factorial?
Are we including 0 as well?
Down. No. Can I just say this is really 1, 2, 3, 4, 5?
Oh, that's what you're counting. Okay.
Yeah.
Yeah, that would be 5 factorial.
Makes sense? It's a half of 5 factorial, right? So your intersection is going to be half of the cases that B happens on the right side of the C. So then you have 4 factorial times 5, and that is it. Okay, this is fine. Question here? Any question here? What's the probability of A given B? What is the probability of A given B? So this is going to be probability of intersection divided by the probability of the B, okay? So what's the intersection? A intersected with the B. A intersected with the B. A is the one that says B to be middle. 1, 2, 3, 4, 5, 6. 7. 1, 2, 3, 4, 5, 6, 7. B is in the middle. Then B is the one that says C appears on the right side of the B. Oh, because that's a B, let's just think about that B, and then C could be here. And if that's a B, C could be here. That makes it simpler, right? C could be here. So you have a 5 factorial cases happens here, 1, 2, 3, 4, 5. You have another 5 factorial happens for this permutation, and then 5 factorial happens here. Actually, your intersection is 3 times 5 factorial. Agree with this, me? Does it make sense here? What intersection? You okay with my intersection? Probability of the B. It was 7 factorial half. Okay. A, B, C, D. Okay. I think I need my simplified answer, and I don't have it, unfortunately. No way. Okay. You know, because the last part of the answer, the last part of the question says, can you see which pairs of A, B, C, D are independent? Because if you remember, to be independent, like saying you're getting the probability of A given C. So if you can show is the same as probability of A, that means A and C are independent. If you have probability of, this is B given C. If you can get it's the same as probability of the B, then you can say B and C are independent. And then the last one you got is probability of A given B. So if you show it's the same as probability of A, then A and B are independent. Okay. I don't think I have the simplified answer. Let me just check one more time. Oh, actually I do. It seems that the first number after simplification is 1/10. The second number after simplification is 1/2. And the last one after simplification is 1/7. So which one is the same, because we have numbers here. So I have to see what's the probability of B, also is 1/2. And then what's the probability of C after simplification? Maybe I don't need that one. Okay. So according to this number, seems probability of A given C is not the same as probability of A. Why? Because for one of them you got 1/10. For the other one you got 1/7. So that is not. And then for probability of B given C, B given C, we got 1/2. Probability of the B also is 1/2. So this is independent. B and C are independent. B and C are independent. B, C independent. Probability of A given B and probability of A. A given B is 1/7, probability of A also 1/7. Oh, A and B are also independent. That's interesting. So this shows A and B are A and B also independent. That is interesting for me. I'm going to check one more time what's A and B. A is the one that says B to be in the middle. B is the one that says letter C appears to the right side of the B. They are independent. B and C also independent. I mean, makes sense B and C is independent, but it's interesting why A and B is independent. No, because both of them depends on B, the position of the B. Only A and C are not independent, okay, but the rest are dependent. Make sense? So that's good practices for your probability because you do have a quiz on this part. Your quiz is much easier than that. It's not that much complicated. Question here? Any question here? So five card hand is just from the perfectly shuffled deck. Define the events of A to B. Event A is the one that 4 of a kind, 5th is any, and then event B is at least one of the cards is an ace. Okay. And the question is whether they are independent or not. The same question. So you have to get the conditional probability and then you have to get the probability of A. What is the probability of the one that I computed A given B, which that means you need the probability of intersection of A and B divided by probability of the B. And then if you want to show they are independent, you have to show probability of A given B is the same as probability of A. Or if you want, you can show probability of B given A is the same as probability of B. Either one is fine, okay? So I tried A given B. So you need what's the size of A intersection B divided by what's the size of B. $52, right? So your B is at least one of them to be ace. I think it's easier to go with that. B is at least one of the B bar. B bar is easier, which is sample size minus B. Sample size minus B, okay? Your sample size, you're selecting, as you said, 5 out of 52. Minus, so when you say at least one of the card to be ace, the complement is, so if you say at least one of them to be ace, what's the complement?
48 over 5.
Yeah, that's true. That means none of them to be ace, okay? So none of them to be ace. None of them to be ace. Okay. Can I just write the same place? What is the sample? What is the A? What's the size of A? Or how many cases counting, not probability? You know, for probability, you have to divide by total, right? So if the question asks me, what's the probability of the B bar, actually is probability of, did I write this one correctly? Actually, sorry. I mean, B is B bar because we computed the B bar, sorry. So what's, does it make sense notation wise? Your probability of having at least one card of the ace is sample size minus none of them to be ace. That's what you write over here. I was just explaining if you're writing the sample size, if your question asks you the probability, that's going to be the B size of B divided by size of S. For all of the cases. So for all of the cases, as you see, I don't write the sample size denominator, right? So I do not write the sample size on denominator because they cancel out. So that's why I just need the size of in each of these sets. So give me what's the probability of 4 of the kind, and then the fifth one, whichever. One, two, three, four, 5 cards. 4 of a kind. How many kind do you have? You have 13 of them, right?
Mhm. You can choose, but
Choose 4.
That boring.
You have to first you have to select your kind. So you have one out of 13, or you have 13 choices. So first you have 1 out of 13 because you select which of this kind you have. You have ace, you have just jack, or whoever. Okay. So
after
then
you pick your card that limits it more. So
So let's say in your first step, you choose one choice out of 13, which is a jack.
but
So
you have
then
3
Then you
choices.
have, how many left you have to be jack? You have one, you have really 3
Oh,
more
just-
jacks. So you
yeah.
have no more. So then that means you have 1, 1, 1. So that's all you have. No more chances, right?
Mhm.
So it's 1, 1, 1. So then that means you have a 13. And then for the fifth one, how many chances do you have? Because you said you choose already 4 of them.
12.
All of the 48 cases,
Oh,
right? So you have still 48 cards, whichever it is, for your fifth card, okay? Okay, so now, what was the intersection? Did I make the not yet? Okay, so let's think about the intersection. Can we think about the intersection? What is the intersection possible cases? So what would be if you have five cards, 4 of same kind, and at least one of them ace?
or I think 12 of them. So like going from 2 to the jack, king, and queen. You have the ace as the 5th card. And then for the other one, there's the pairs where all 4 of them are the ace. So I think that's 12 factorial and then plus 1.
So you have to separate. So think about the top one that you see. Let's take care of the one that you have 12 non-aces to choose. You have 12 non-aces to choose. And then what is the selection at the left for the fifth one? Why 4?
Because there's only 4 aces.
So for there are 12, so there are 12 for non-aces cards, 12 choices for non-aces cards, and you said there are 4 aces to choose for the fifth card. This is a choose of fifth card, okay? And then now the other one. Can you explain one more time what's the other one? The other one that you said 4 of them to be aces, huh? If 4 kind are the aces, so what's the choices for, because that's all, you don't have any more aces to choose, right? So if your kinds, which are the same, are 4 aces that you have, what's the choice for fifth one?
The rest of the
48. So that's a total 96 possible cases. So that's either of these two, right? So either the top happens or the bottom happens. So that's why it's addition. So it's going to be put, so I'm going to write down over here. So what did we say? There are one case which you have 12 non-aces, and then there are 4 ways that fifth card to be ace. And this is what you said, 4 kinds to be all A's. 4 kinds are aces. There are 48 ways to choose 5th card. So that 96 size of the B is bigger. So can I just write down over here? So we don't have the actual number, right? It was 5 out of 52 minus 5 out of 48, which is no chance to be the same as probability of A, right? So there was no chance to be the same as probability of A, because probability of A is 13 times 48. There's no way to be. So this is, if it's not the same, this is not independent. This is not independent. It is dependent, okay? So the answer is no. Are they independent? No, they are dependent. Even if you think logically, it depends, right? So when you're having a hand which has 4 kind, and then you're supposed to choose at least one of them to be ace. So if the ace comes in one of the card, so that change the chances for the other cases. So that makes sense to be dependent, really. That's we have done this type of problem. I'm not going to do this one. Any question here? Any question here? What was it? Yeah, just again, counting worksheets that we had, it was a really good one. If you guys can practice those counting problem and make it a probability problem, because it has a good problem. And actually, I did many examples during the class time too. So problems that we tried in the class and the worksheets are making really good package for practices, okay? That sample exam that I posted, it's not going to be enough, right? So it is not going to be enough. So you have to really practice, as I said, all of the problems that we did in the class and the worksheets, okay? So I'm just really bringing up one of those problems because we have a little bit time before the quiz time. So which one do I try? So do you like the sequences? So the last part, which is on the sequences, and this is, I mean, the first part A, you, for both of them, because it's just really the one that we make it as a polynomial, characteristic polynomial, and solve the characteristic polynomial corresponding by that, then you can get the actual solution in a form of, so if you remember, your solution was something, whichever solution that you got from the polynomial, characteristic polynomial to the power of n, and then another constant, so whichever solution you could get from the characteristic polynomial. If you have had repetition, you have to multiply by 1n. So if your solutions was repeated, you have to multiply by 1n. So part A, your xn equals 4xn minus 1 minus x minus 2 minus 6xn minus 3. Your first one is 3, and then 4, and then 14, okay? So if I move everything to the one side, did I move everything correctly? That was a plus, now it's minus, minus, now it's plus, minus, now it's plus, okay? So if this is a 6 with the with the 0 power, so that has to be 1 with the, I don't know, what do we call it in your lecture? Did I call it alpha? Because we have already x. Whichever, okay, so just one thing. And then your 1 less is 4 alpha to the power of second. And then the previous one is going to be alpha to the power of third. So because of that -3, you have, sorry, it was highlighted. That -3, so then you have a third power. So then let's see. This is something that we can't factor it out, right? So we have to do it by calculator for getting solution for this one. If you stack such a this one, or you haven't had your calculator that can solve the equation, like equation, you have to let me know, okay? So, but that is not being factorable. What do you think? If you factor 1 alpha squared, that makes one left. So then if I plug in 1, it gives you 6, 7, 8, so it doesn't work. If I plug in -1, if I plug in -1, -6 plus 6, so -1 works. So if -1 works, that means one of your solution is +1. One of solution is -1 actually. Then how about the other solution? The other solution. I don't know if you guys remember how you guess the solutions in your earlier pre-cal classes. 8 times 4. 8 times 4. 32. 2. Does it make 0 or no? If I plug in 2 plus 6 is 8. Oh, okay. 4 times 4 is 16, so it makes 0. So only 3 left, right? So because it has to make 6. 1, 2, 3 left. It has to make a -6, so it's -3. Okay, so you have to do this for my calculator if you don't remember what's in pre-cal, but I can just quickly remind you the possible solution that I have tested. The possible solution I have tested was just really the factors of 6, because 6 can be written as 2 times 3 times 1. So I have tested that one. So that's how you got 1, 2, and -3. So that's how I got that number. I've tested because that was the best possible cases I could guess. And we always start from the 1 because 1 is the easy one to check, okay? And then I don't expect you guys remember this one for pre-cal. But it's fun. It is really fun that you can solve any degree of this polynomial by just guessing the product of your constant. Do you guys remember that one you have learned in pre-cal? Yeah. Yeah, I know. I agree with that. That's why I just said you just need either use the calculator or ask me. You know, because that's not fair if you guys lose the points because you don't have good memory or it's just something not related to my course, okay? Even though you have to know all of those stuff, right? So this is, actually, this is the solution according to this pattern. The only thing is you're supposed to plug in the values. You just say if n equals 0, so that is going to be 3. C1 -1 to the power of 0 plus C2 2 to the power of 0, I mean 0 plus C3 10, which one I missed? That's a 3. 3 to the power of 0. And then that gives you one solution. I mean, that gives you one equation. You plug in 1 and you plug in 2, and then you can solve that one. If you plug in 1, It's 4 equals C1, that's negative 1 to the power of 1, and then 2 to the power of 1, and then 3 to the power of 1. And if you plug in 2, your second, I don't know what is x2, 14, that was given 14. So it's C1, negative 1 to the power of second, and then 2 to the power of second, and then that is to the power of second. So this makes a C1, oh, sorry, here. It makes a C1 plus C2 plus C3 equals 3. That makes a negative C1 plus 2C2 plus 3C3 equals a 4. That makes the, what's the last one? The last one is just a C1, then you have a 4C2, and then 9C3 equals a 14. So this is a system of equation that you guys can solve with the matrices, okay? So if you, again, stuck in 3 by 3, this is just for practicing for the test, okay? You know, elimination method is another way, because you can just really eliminate this one and solve it for C2 and C3 and plug into the other one, okay? So anyway, if you stop over here, that is perfect, okay? For 3 dimensions, I really don't expect you to just spend that much time in a test for that one. So, but let's, actually, I don't have the solutions. I was going to copy paste the questions, the solutions for you, but I don't have it. Okay, question here? Any question? No question? So one more time, if you guys have more questions or you have any extra concerns, anything, so tomorrow night, okay? So tomorrow night, join to the meeting for, I will send anyway reminder, you can click on that announcement to just join to the meeting. And if not, so your test on Wednesday, okay? So your test is on Wednesday, that's the second test. It is a big portion of the grade, right? It's a 25% of your grade, don't miss it, okay?